So we've talked about the difference between correlation and then regression. We've actually discussed that already, which I told you that correlation is nothing but finding the relationship, right, or the association between variables, right, between variables. That is correlation for you. That is finding the relationship, right? Finding the relationship that is between variables, right? And then this relationship could be negative or it could be positive, okay? And then regression is helping us. Using this relationship to help us make future predictions, right, by using the regression line, right? And that's what we're going to actually see over here in this notebook, right? That's what we're going to see over here. Now, what we're going to do is to build, so this is actually our first program that we're going to do, our first model that we're going to build over here, right? So I'm going to take my time and then take you through step by step so that you get to understand what we're doing and how we are building this linear regression model, okay? Now, what we are going to do over here is that we're going to build a linear model, right? You can call it a linear model or a linear regression model, right? To express the relationship between a car's mileage, right? Which is MPG. You will see it when I import the data set. And then the rest of its other attributes, right? So in this case, right, we are not going to only have our Y, right? So MPG here, right? Our MPG here is going to be our Y, right? And there are some other factors. There are a lot of factors, right? Maybe X1, S2, right? S3, plus all the way to the last S, right? Maybe XN over here. So all these are going to help us to actually make predictions of the MPG. That's what we're actually going to do. So we're going to build a linear model that will express a relationship between the MPG, right, the car's MPG, and these other attributes, right? That's what we are actually going to do over here. Okay. So now let's progress and then see the next step that we do. Now, in order for you to even progress and then load your data set, prepare your data, and then start building those algorithms, the first thing that you need to do is to load your libraries, right? If you remember from the NumPy class and the Pandas class, we've been loading those libraries, and even in the visual data visualization class, if you remember, we loaded certain libraries that we were going to use. Okay, so the same thing over here. So everything that we've learned in the past, we're going to put everything together over here. Okay, we're going to put everything over here. So the first thing is to load the various libraries that we're going to use in this course, okay, or in this particular project of building a linear model. Okay, now the first library that we thought wise to import, right, so that we're going to need it as we progress is the NumPy library, right? That's why earlier on I first introduced you to NumPy, and then I also introduced you to Pandas and also matplotlib.pyplot. If you remember, we learned all this in our previous classes, okay? And also there's Seaborn, right? We also learned Seaborn, right? So we've imported all these libraries that we know about them already, right? All these libraries, we already know them, okay? Now, what is new over here? What is new over here is this scikit-learn, right? That's the sklearn that you can see over here, right? So in sklearn, right, we are going to import a linear model, right? So since we want to build a linear model, right? What we need is a linear model. We need to import this linear model from the sklearn package, right? So sklearn package is, it's going to give us, it's going to help us to import this linear regression, right? Linear model, right? And inside this linear model, right, we can actually find the linear regression, right? We can find a linear regression inside the linear model. So that's what we are actually doing over here. Okay, so we are getting this linear model from sklearn, and we are getting this linear regression from the linear model. Okay, that's what is actually happening over here. Now we first say that from this sklearn, give us a linear model, and then if you give us the linear model, we want to import the linear regression. Okay, we want to import the linear regression. Now, if you see the second one again, right, we are saying that from this sklearn, right, give us model selection, right? Model selection. Inside the model selection, we have what is called the train test split, right? If you remember earlier on, I told you that when we want to build an algorithm, we divide our data set into certain ratio. I used 70-30 as an example, where we're going to use the 70% for training, right? We're going to use the 70% for training, then we're going to use 30% for testing. right? We're going to use 30% for testing. So this train test split is actually going to help us split our data into whatever ratio that we want, right? So this could be 80-20, right? It could be say 75, right? It could be say 75-25, something like that. Okay, so this train test split is going to give us the flexibility to do this, right? To divide our data into training and then testing. That's what we want over here. And if you see this percent matplotlib inline, right, this one is actually going to help us to plot every visualization inside this this Jupyter notebook that I'm using over here, right? It's actually going to help us plot everything inside the Jupyter notebook. That's what this matplotlib inline is actually going to help us to do. Okay, so I hope this is clear. Let's progress from here. Now, the other alternative, so instead of importing these libraries one by one, right, what I can do is to use what is called the PyForest, right? So let me uncomment this, right? Let me uncomment this so that we can actually see what that one does. Okay, so I'm saying that from PyForest, right? So this one is an alternative to this, right? Instead of importing everything one by one, I can also do this, right? So from PyForest, I'm saying that import star means I import everything, just like in your SQL, we use star over there to get everything. Now, what is happening here is that I'm saying that from PyForest import star, meaning that from PyForest import everything. Now, in order for me to see the libraries that I've imported, right, I'm using lazy underscore import, right, because this one is a lazy method. If you think about it, instead of importing them one by one, I want to import everything at once. So with this single line of code, I can import everything that I've done over here. Okay, just using the PyForest. Okay, and in order to see the libraries that you've imported, I can use the lazy underscore imports to actually do that. Now, if I do that, right, and if I run this, right, you can see the various libraries that I have. You can see the libraries that I've been able to import it, right? So let me zoom a little bit out. Now you can see all these libraries, right? If I had not used this, just this single command, I would have imported all these one by one. But I just, if you want to import everything at once, you can use this code to actually do that. Okay, you can use this one to do that. So instead of maybe importing them one by one like this, you can just use this PyForest to actually get the same results. Right, so you can see we have import pandas, right? You can see over here import pandas as PD. So everything that we were importing by hand, everything is being imported over here for us. You can see the train test split over here. You can see it over here. Okay, so everything will be imported for you. Now, after that is done, right? The next step is to actually load your data set, right? The next step is to load your data set. Now, what we're going to do is to load this AutoMPG dataset, or AutoMPG.csv. So I have this dataset on my system, right? I have this dataset on my system. So in order for me to get it here in the Jupyter notebook, right, what I'm going to do is to actually read this, right? So I'm going to use read underscore CSV. Okay. So if I'm sure by now you are familiar with it. If you've gone through the pandas and the NumPy class, you are familiar with this read underscore CSV. So what it's actually doing here is that I have my file, right? I have my file which is stored in a CSV format, right? Which is comma separated, right? Comma separated format. Okay. So I'm using a read underscore CSV, right, to read it because my file format is a CSV format. So I'm using pandas, and then in pandas we have what is called the read underscore CSV function, and I'm going to use that one to read my data set. Okay, and if I read everything, right, if I read this, I store it in a variable called data. So moving on, I'm going to use this data because I've stored everything over there. Okay, I've stored everything over there. So now let's move on and see what is inside data. So if we do that, right, this is what we have. This is what we have in our data, right? We have MPG, we have cylinders, we have displacement, we have horsepower, weight, acceleration, model year, origin, and then car. Let me open this one so that we can actually follow along what these variables mean, right? So if we see the MPG, right, it's just the miles per gallon, right? It's just the miles per gallon of the car, right? Okay, we adjust the miles per gallon of the car. Okay, so these are the variable attributes that the variable descriptions that we have down here. If you take the cylinder, some cars are having say 4 cylinders, right? Some cars also use 8 cylinders and so on. So that's what is being represented over here as cylinder for us, right? Then we have displacement, which is the engine displacement of the car, which is being measured here in inches. Okay, and then we have the horsepower of the car, right? We have the horsepower of the car, and then the weight of the car, right? The weight of the car is also being measured over here. And then we have the acceleration, right? Time to accelerate, from which ranges from 0 to 60 miles per hour, right? And that's what we have over here as the acceleration. And then the model year is also being recorded over here. And then the origin. Now if you see the origin column, right, if you see the origin column, if the car originated from, say, America, they represented it with 1. Okay, and if the car originated from, say, Europe, right, they represented it with 2. And if the car originated from Japan, they represent it with 3, right? So that's what they did over here, right? That's what they did at the origin column, right? So that's why you can see some 1 and then some 2. So if it's 1, it means that the car originated from the United States. If it's 2, right? If it's 2, it means that the car originated from the Europe. Okay, and then we have the names of the various cars over here. So this is the data set that we are going to use moving on from here. This is the data set that we are going to use. Okay, now let's see the shape of this data set. That is the number of rows and the number of columns that we have, right? So we have 338 records, or 338 rows with 9 columns, right? With 9 columns over here. So you can see 98 rows, right? You can see it down here. 398 rows with 9 columns, right? So that's what is actually the shape is going to give us. So if you want to count, you can see the 1, 2, 3, 4, 5, 6, 7, 8. Well, let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then the rows, right, is all the way to up to 300. Don't forget that this is 397 because it's starting from 0, right? And this is 398 rows. Okay, don't forget that it will break somewhere here, so it will not print all the 398 rows. Okay. Now that is what the shape function can actually do for us right now. What we're going to use over here is this LM plot, right? We're going to use this LM plot to make some linear regression plots, right? To make some linear regression plot over here. Okay. Now if you see what we are doing over here, we are picking the MPG, right, and then the acceleration. So we are trying to find the relationship that is existing among MPG and then acceleration, right, the car's acceleration and the car's MPG. Okay, so we're going to use this LM plot, right? I'm sure by now you're familiar with this. If you've watched the Matplotlib class or the data visualization class, I'm sure you're familiar with this LM plot. Okay, so that's what we're going to do over here to find the relationship between these two variables. Okay, and then we pass in our data, right? So our data here is equal to this data, right? Remember that when we loaded our data, right? When we loaded our data, we stored everything in data. And that's what we are passing in, right? That's what we're passing in over here, so that it will get to understand. Right? We're using Seaborn, right? So that Seaborn will get to understand that the data that we are using while we have MPG and the acceleration, right, is found in this variable called data. Okay. Now if we do that, right? If we do that and then we plot, this is the graph that we have over here, right? This is the graph that we have over here. Now let's see this one so that we can actually compare it alongside, right? If you see the correlation, remember that earlier on I explained what is correlation and what is regression over here. If you see the correlation over here, right? Let me zoom in a little bit. Yeah. If you see the correlation that we have here, you can see that we have 0.42, right, which is a positive correlation, but it's a low positive correlation, right? We have very low positive correlation, right? That's why this one you can see how the regression line is moving that way, right? How the regression line is moving. So you can argue that maybe the distribution is something like this, right? So it's positively correlated, right? Positively correlated. Had it been like this, right? Had it been like this, right? Or the regression line going down like that, then if the regression line was going down like that, then we could have said that it's a negative correlation, but in this case it's going up like this, right? And if you check the correlation, it's actually confirming that we have a positive correlation, although it's very low, right? But we still have a positive correlation. Okay, now you can see where the regression lies and how the points have been scattered over here, right? So the correlation is not strong, right? What we want is that we want most of these data points, right? We want most of these data points to lie on the regression line, right? That's when we can actually say that we are actually making a good prediction, or we can actually say that we've built a good model, right? So if we get a model that will capture most of the points, right, where most of the points will lie on the model, then we can see that we've actually built a good model. But if you see this one, you can see that most of the data points are lying far away from even the regression line, right? Most of the data points are lying far away from the regression line. Okay, so although there's a relationship between the cast MPG and the acceleration, but it's not that strong. So what this positive correlation is telling us is that the higher the acceleration, right, the higher the cars miles per gallon. Okay, so if we say that, if we see here, if we have a 10 here, right, you can see that those points over here are having low MPG, right? But if you go a bit higher, like say 22, right, and you trace a point like 22, or maybe if you want to even trace it all the way to maybe somewhere here, right, you can see that these ones have high MPG, right? So that's basically what is happening over here, right? Higher acceleration, right? Higher acceleration is actually leading to higher MPG, right? So that's what the positive correlation over here is actually going to help us to understand. All right. Now let's move on and then see the next step that we can actually take over here. Okay, now let's do the same thing for MPG and then cylinder, right? Let's do the same thing for MPG and cylinder. Now you can see that this one was positive, right? Positive correlation. So you can see where the line is, the regression line is, and you can see how the data points have been displayed, all right? However, if we take this one, you can see how the regression line has been plotted, right? Which is, moving down like that, right? So this is a negative correlation. If we check the correlation of this, right? We check the correlation of this, and that's the correlation between MPG and then cylinders, right? We can see that we have negative over here, right? We can see that we have negative 0.77, which is a very high negative correlation, right? We have a high negative, right? We have a high negative correlation, right? A high negative correlation that is between MPG and then cylinders, right? So what this one is saying that as the cylinder increases, right? As we increase the number of cylinder of the car, we have a lesser MPG. We have a lesser MPG, right? As we increase the number of cylinders of the car, we'll be having lesser MPG. So if you see over here, right, the higher it goes, right, if you trace it to the regression line, we'll be having lesser MPG. But however, if the cylinder of the car is small, right, maybe 2 cylinders, if the car is using say 2 cylinders, then the MPG of the car is actually going to be higher. Okay, the MPG of the car is actually going to be higher. All right, so that's what this negative correlation is actually telling us. As this one increases, this one reduces, right? As this one is increasing, this one is reducing. Unlike at first, right? If you check what we have above here, right? If you check this one is positive correlation, right? As this one is increasing, right? This one is also increasing. All right, so that's mainly the difference that you can actually draw from here. Okay, now let's progress and then see MPG and weight. So we are picking these attributes, MPG and cylinder. We did it for MPG and cylinder, right? Down here we did it for MPG and cylinder, and then we also did it for MPG and then acceleration, trying to find the correlation, right? And then also the with respect to the regression line, right? So we did that. Now what we're going to do over here, right, is the MPG and then weight, right? The car's MPG and the car's weight, right? So MPG and then the weight. Remember that MPG is our target, right? The miles per gallon of the car over here is our target. Earlier on, we mentioned that we're going to build a linear model to express the relationship between a car's mileage, that is MPG, and the rest of its other attributes. So that's what we are trying to get ourselves familiar with, the relationship that is actually existing, right? So all these are some of the exploratory data analysis that you need to do before you move on to build your model, right? To get a fair idea of how the various attributes are relating, or how the various attributes are correlating with the target variable, right? That's why we're picking the target variable and then checking the relationship that is existing between the target variable and the other variables, okay? Now, if we do that for the MPG and then the weight, right? If we do that for the MPG and then the weight, see what we have over here. Okay, let me show you the correlation. All right, now if you see the correlation over here, right? Let's see. You see that we have negative 0.83, which is a very high negative correlation, right? A very high negative correlation. That's why you can actually see it like this, right? So we can see that most of the points are trying to lie on the regression line, right? Most of the points are trying to lie on the regression line, unlike the other one that we watched earlier on, where we had a positive correlation, where most of the points were lying far away from the regression line, because although it was a positive correlation, but it was very less, like 0.43. But in this case, you can see that it's a negative correlation, right? Which is this negative 0.83, right? Negative 0.83, right? Which is a very high correlation. It's closer, right? It's closer to 1, right? And this one is closer to 0, right? So this one, it will be a low correlation, but this one will be a very high correlation. Okay, that's why you can actually see this line all the way moving down, and most of the points are trying to lie on the line like that. Okay, so what is actually happening is that the higher the weight of the car, right? The higher the weight of the car, the lesser its MPG, right? So as the weight increases, the MPG of the car reduces, right? So if you take, say, like 4,000, right? Let's say a car weighs at 4,000, right? So if we trace it over here, you can see that the MPG of that car will be very less, right? But if the car is weighing maybe like 1,500 here, right? You can see that car, even if we trace it to here, is having a higher MPG. Okay, so as the weight increases, the MPG reduces. Okay, so that's what this one is actually telling you over here. Okay, that's what the correlation here is trying to let you know. Now, if we have a new data point, right? A new weight. So let's say we have a new weight like 3,500, right? Let's say we have a new weight like 30,500, and we trace it over here. Can we now predict, right? If we trace it to the regression line, right? This is the regression line. If we trace it to the regression line, can we predict the weight, the MPG of the car, right? Of course we can predict it. We can trace it here and then say maybe 17, right? The MPG of the car will be 17. So that's what we want to do, to use the regression line, and then help us to predict new data points, right? New data point that will come in, right? To use the regression line to help us to predict this MPG. Okay, that's what we use the regression line for. So after this correlation has helped us to know the correlation that is existing between the MPG and the weight, we can actually use the regression line now to make that prediction. And that's what we're going to build the model to do. Okay, to make it automated, so that any data point that will come in later on, we can actually make the prediction straight away without us drawing these and doing all this analysis again. Okay, that's what we actually want to do finally. All right, let's see the next step that we can actually take over here, right? Let's see the next step that we can take over here. So all this is an explanation of what I've been telling you right from here, right? There's the explanation, the total explanation that you can actually get. Now, if you see what we have here, right? If you plot the graph and then you see it like this, right? Which is going up like that, right? Going up like that, then you can see that it is a strong positive correlation, right? If you're supposed to draw the line to pass through this, you can see that most of the points will try to lie on the regression line that you are trying to plot, right? Most of the points will try to lie on that, and this becomes a strong positive correlation. That reaches, closer, right? Which is this is going to be closer to 1, right? This is going to be closer to 1. And if it's like this, right? If it's like this, and you draw your regression line, right? You can see that although it's positive correlation, and some of the points are closer to this regression line, but it's not as close as this, right? It's not as strong as this. So maybe this one will be positive correlation, but remember that like the 0.4 that we saw earlier on, right? And this one will be maybe the 0.8, something like that. Okay, so this one will be closer to 1, this one will be closer to 0. Okay, so I mean, positive correlation, but closer to zero, right? And you might have a condition where there will be no correlation among the data point that you're trying to measure. So if you take, say, maybe MPG and some other data points, right? Some other data point here, you might end up finding out that there's no correlation existing, right, among these two variables. Okay, and there's a situation where, as we just saw, where you'll be having negative correlation, right? But if you try to plot the linear regression line, you might find out that although it captures some of the data points, but not all of them are more closer to, some of them lie a little bit far away from the regression line, right? So that becomes a moderate, right? That becomes a moderate negative correlation, just like we have a moderate negative positive correlation, right? And if you have it in this way, right? If you have it in this way, you try to plot the regression line, you can find out that most of the points are trying to lie on the regression line, and this becomes a strong negative correlation, just like we have a strong positive correlation over here. Right, there's a situation where it's not actually going to go, it's not actually going to be negative, or it's going to be positive, right? So you might end up having something we call the curvilinear, right? You might end up with something we call the curvilinear, okay, where it will not actually be negative, it will not actually be positive, right? So in that case, you might be having a curvilinear relationship, okay? So let's proceed and see the next step that we can take from here. Okay, let's see the next. I'm going to talk about this when I'm talking about I'm going to talk about this graph when I'm talking about the root mean square. All right, how we are going to measure the error that is existing among our data. So I'm going to talk about this after we build the model. Okay, so we'll come back to that. Now, what I'm going to do over here is to find the 5-number summary, right? To find the 5-number summary. 5-number summary is, it's nothing but if you take the box plot, right? If you take your box plot like that, right? Well, we have the whiskers and then the box, right? So we have this and then we have that, right? So this becomes the minimum, right, of the whisker. This becomes the maximum, right, where we also have the Q3, then we have our Q1, then we'll be having our Q2 here, which is nothing but the median. Okay, so this is nothing but the 75th percentile, right? 75th percentile. This is the 25th percentile. Okay, this is the 50th percentile. Right, then we have our maximum and minimum. So the 5-number summary is nothing but this, which is 1, 2, 3, 4, and then 5, right? Which is the minimum, the Q1, the Q2, the Q3, and then the maximum. Okay, so that's what, if you use the describe function, right? If you use this describe function, that's what you're actually going to get, right? So I use the describe function on my data set, right? And this one is actually going to work only on the numerical columns, right? Only on the numerical columns that you have, okay? So if you see up here, right? If we go a little bit up here, to see our data set, you see that we have this car name, right? Car name here. So it's not going to work on this object or data type. It's not actually going to work on that. It's only going to work on the numerical columns that we have over here, okay? The describe function only works on that, and it's going to give you this 5-number summary where you see that we have our mean here, we have our standard deviation with the mean, we have the minimum, the 25th percentile, the 50th percentile, the 75th percentile, and then the maximum. Okay, so if you use this, right, if you use bring this back, okay, if you use this describe function, right, so I'm using my data.describe, right, so this describe is what I'm using. If I don't use this one is just to transpose it, right? If I don't use that, let me take that one off and then show you what you can expect if you don't use that. Okay, if you don't use that, so I have to actually run this again. All right, let me just run this from here. Okay, let me just run this. Okay, so let me run it all the way down there. All right, so if I show you this, right, this is what we have, right? This basically what we have over here. Now, what this one is actually, let me do it over here. Without a T. This one is without a T, right? So this one here, I'm not adding the transpose, right? So you can see where they count the standard deviation, the mean, the 25th percentile, and then the 75th percentile, the maximum. This one is fine. It works very fine, right? You can actually make the inferences from this. Mostly I like transposing it. And when I talk about transposing it, right, when I'm adding the capital T here to transpose it, what I'm doing is that I'm only switching this part, right? I'm switching this, right? I'm switching this, right? Taking this one here, right? This is the position that I'm switching. So I'm taking this one here and taking this one here, right? That's what I'm doing. I'm just switching these positions, right? The orientation of this matrix, I'm just switching it in that way. Okay, that's what I'm actually doing if I use the transpose. Okay, now if I run it again, you can see that this one will be coming up here, and this ones that you can see here will be coming down here. Okay, so let me run it so that you can get to see. Now you see what we have, right? Now you have the count, the mean, the standard deviation, the minimum, 25th percentile, 50th percentile, 75th percentile, and the maximum. You see that we have them over here, and then we have the other attributes over here. Okay. Let's try and then make some inferences from this describe function that we just did over here. All right, let's try and then make some inferences over here. Now, if we take say the MPG, right? If we take the MPG of the car, we can see that the maximum MPG of the car is 46.6. Okay, the maximum of MPG of the car is 46.6. Now we can say that on average we have 23.5, right, MPG of the car. Okay, of all the cars that we have in our data set, on average we have 23.5 on average we have 23.5 mpg. Okay, and if we talk about say cylinder, we can see that the maximum cylinder that we have is 8, right, and then the minimum cylinder that we have is 3. Okay, the minimum cylinder that we have is 5. On average, a car is having a 5 cylinder. All right, I mean, on average, every car is having 5 cylinder, right? So it can be less than that, it can be more than that, but on average, we have 5. Okay, we have 5, and it can be as low as 3, it can be as high as 8, right? That's with respect to the data that we have. Okay, it could be changed. I mean, it could be different. I mean, in the real world. Okay, it could be different in the real world. Now, if we take say the weight of the car, right, we can see that on average we have 2,970, right? On average we have 2,970 if we talk about the weight, and the maximum weight of the car that we have is 5,140, right? That's the maximum weight of the car that we can actually expect. Okay, so these are some of the inferences that you can do for all the other attributes that you have over here, right? For all the other attributes that you have over here. You can actually consider each of them. I mean, the 25th percentile, the 50th percentile, the 75th percentile. You can consider all of them, right? So just this describe function will give you the flexibility to get to know all these, right? To get to know all these features at once, right? Without you doing them one by one. Okay. Now what we can do is to drop this car name, right? Remember that we have in our data set, right? Maybe I should just print it up here, down here, so that you get to know what we are dealing with, right? So I'm going to, let me do this. Okay, so now we have our data. Right, let me just print the head of our data over here. Okay, so this is what we have, right? This is what we have. So what I'm going to do is that I'm going to drop the car name, because I'm not going to use this car name. I mean, when I'm building my algorithm, I'm not going to actually use the car name, right? What I'm going to use is these other variables, right? Which is starting from cylinder all the way to origin to help me predict the MPG, right? So the car name is not actually going to contribute in any way. So I'm going to drop that in this case, right? So what I'm doing over here is that I'm using the drop function. Right, if you remember this in the NumPy class, or in the pandas class, right? Remember that we used this drop function to drop some of the columns, right? So the same thing that we are doing here. So you see that now we are using every concept that we learned in our previous class over here. We are dropping this car column, right? And don't forget this car name column, right, is actually present in the column of the data set, right? So that's why we are specifying that what we want to drop, which is the car name, right, which is the car name, is present in the axis of the, in the column of the car, and that's why we're using axis equals 1. So axis equals 1 represents the column of the car. If we use axis equals 0 over here, right, it's actually going to give us an error saying that it cannot actually find You cannot find that. You cannot find that name. So let's go and see the error that is given as well. Car name not found in access. You see that. Now what it's doing is that it's going here. It's going to look over here to find the car name. Meanwhile, it's not here. It's actually in the column name, right? So you have to specify that whatever you're going to drop is present, right? Is present over here, right? It's present over here, right? So if I run that, you see that now it's working perfectly for us, right? It's working perfectly for us. Now, over here, what I'm going to do is that you see that the column, if let me zoom a little bit, yeah, this origin, right? If the car is from the United States, right, or from America, they actually labeled that as 1, right? If the car is from Europe, they labeled it as 2, right? And if the car is from, say, from Asia, they labeled it as 3. So what I'm going to do is that I'm going to change that. Otherwise, if I want to build an algorithm on this, right, it's actually going to rank this, right, where 1 represents America, but it will not know that 1 represents America. Is what is the model is going to understand is that if you take, say, 2 is greater than 1, right, and 3 is greater than 2. So what is going to happen is that our model is going to put a rank, right? So what is going to happen is that if we pick, say, 3, we know that 3 is greater than 2, and we know that 2 is also greater than 1, right? Meanwhile, this 1 represents America, these 2 represent Europe, right? These 2 represent Europe, while and then this 3 represent Asia, right? So if we rank this, then what we're saying is that cars that are coming from Asia are greater than cars that are coming from Europe, and cars that are coming from Europe are greater than cars that are coming from America. We don't want to make such an assumption which does not even make sense, right? That cars are greater than one another. Doesn't actually make any sense. We don't actually want to make such an assumption, okay? So in order to get around this, right, what we're going to do is that if we see 1, we replace the 1 with America. If we see 2, we are going to replace the 2 with Europe. If we see 3, we are going to replace 3 with Asia. That's what I'm doing here, right? So at the origin column, right, I'm going to replace 1, right? I'm going to replace 1 with America. I'm going to replace 2 with Europe. I'm going to replace 3 with Asia. That's what is actually happening over here. Okay, and I'm using a dictionary, as you can see over here, right, where we have a key and then the value, the key, and then the value, the key, and then the value to do that. Okay, and I'm using the replace function to help me replace this. Okay, so every concept that we learned earlier on, you see that now we are bringing everything together over here in this class. Okay, that's why previously I explained it. I first introduced you to such concept. Now you see, if you see the origin, now we have America, right? Remember that we are just seeing the head of it, right? Let me just cut this over here and then bring it down, right? Let me just bring it down. Now you can see that now we have America, right? We have America, we have Asia, right? If you trace it a little bit down, you might have, Europe also there, right? So instead of the 1 and then the 2 and the 3, now we've been able to replace it with America, Europe, and then Asia, right? So we've been able to replace it with the help of the replace function. Now there's another problem. After we've been able to replace this, right? After you can see that we have Europe here, right? Now after we have been able to replace these ones and twos and threes in our data set with the real meaning of these integers, right? What they really mean, that is 1 for America, 2 for Europe, and then 3 for Asia, right? What is left is that we cannot build algorithm on this, right? This object data type that we have here, we cannot actually build algorithm on this. Okay, what we can do is that if you're building an algorithm, what you need to actually take note of that all your data points, right, in the various columns, right, all the data points in the various columns needs to be either they actually need to be either float, right? Either float or integer, right? They need to either be float or integer, right? But we cannot build algorithm on objects, right? Our model will not understand objects, right? So we cannot do that. All we need to do is to convert any object to either float or integer. Okay, so we're going to do that for this origin column, right? We're going to do that for this origin column because we cannot actually build algorithm on this, right? And this origin column is actually a categorical column, right? It's, as I mentioned earlier on, it's a categorical column that is, it's either America, right? It's either America or Asia, right? It's either America or Asia or Europe, right? So that's a categorical categorical column. Okay. So we're going to convert this categorical column into something that we can actually build an algorithm on, in this case integer. Okay, we can actually do that, or you can, even if you want to refer to it as a unit, we can actually do that. Okay, so let's move to the next cell and then see how we are going to do this. Okay, now in this case, right, we're going to use what is called the get dummy function. Right, let me open this output so that we can work alongside. Okay. Let me open this output so that we can work alongside. Now, what is happening here is that we're going to use this get dummy, right? Get dummies function, as you can see over here, right? So now I have my pandas over here. So in pandas we have this get dummies, right? So I'm using pandas.get dummies, and then I'm going to apply this get dummies function on our data set, which is df, right? That we are working on, and we want specifically, right, we need to specify the particular column that we are going to apply this get dummies function over there. Now let's get to know what this get dummies is actually going to do. Now what this get dummies is going to do is that it's going to create new columns for us, right? So we have earlier on we have a column called origin, right? And then we are applying this get dummy function on this column called origin. Now what is going to happen here is that if it picks this origin column, right, if the get dummies function, right, get underscore dummies, right, that's what this function is actually going to do. So it will pick this column, right? It will pick this column because we want it to work on this column as per our specification. So it will pick this column. Now, if it picks any category here, right? So let's say America. If it picks America, it's going to write the main column heading over here, which is origin, right? So we have origin, and then it will do origin underscore. Then it will pick any category here. So let's say underscore America. Right, underscore America, right, that becomes one column over here. Then it will pick origin again, right? It will do it. So it will just add the column names to the categorical names over there. So origin underscore. Then another category is Asia, right? So underscore Asia. Right, that will be another column. Then it will pick it again, origin underscore Europe, right? It will do that for all of the various categories that we have here. Now, if it encounters America here, it will mark it as 1. The rest will be 0, right? Because if it is America, it cannot be Asia, it cannot be Europe again, right? If it is America, then it's America. It's not Asia, it's not Europe, right? So all the Asia or the Europe is going to be 0, right? So as soon as it encounters America, it will give it 1, it will mark it as 1, it will mark it as 1, all the rest will be 0, 0, right? Just like that, all the rest will be 0, 0. Now, if it encounters Asia, right, then America will be 0, Asia will be 1, then Europe will also be 0. Okay, the same way. So as soon as it encounters Asia, the Asia part will be marked as 1, the rest will be marked as 0. Okay, if it encounters Europe, the Europe part will be marked as 1, and then the rest will be marked as 0. Okay, so that is basically what the get dummies will actually do, just creating some dummy values for us so that we will actually have these categories in different columns, and the ranking between them, right? Instead of saying 1, 2, 3, we will get around that, and besides, we will be able to get around the fact that we are dealing with objects, right? And then we will come into the space of integer or float. Okay, so in this case, you can see that since we have America here, so you see that origin America column, it will be marked as 1, 1, 1, 1, 1. So as soon as it encounters Asia, right, as soon as at index number 394, let's go and see. So if you go a little bit up, we are actually seeing the first 5 and the last 5 over here, right? So at index number 394, you can see that there was Europe there, right? And that's why over here you can see that Europe was marked as 1 and the rest was marked as 0. Okay, so now you can see that this is what get dummies will help us to actually do, right? So that instead of having it in this categorical format, we can actually have it in this still in categorical format, but we can actually work with this as we build the model, right? Because the model will not actually be able to to perform when we're using this form of a categorical column. All right, so that is one important step that you need to actually take into consideration. All right, so let's move on from here. Right now, let's try and then see if we have some data points that were not captured, right? If there are any missing values in there, right? So for instance, if they were recording the MPG, maybe there were some data points that were not there, right? Or maybe some cylinder data points that they could not actually put, or record here for us, right? So let's try and then figure out if there was something like that. Okay, so what we're going to use is this df.isNA, right? So what we're going to use is this is NA to actually identify if there are any NaN values in there, right? If there, let me open this and then bring my pen. Okay, so what we're going to do is to use this is NA, right, function to actually see if there are any NaN, right, values in there, right? That is NumPy way of identifying if there are any null values in there, right, and not a number, right? If there are any not a number values in there. Now, if we do that, you can see that we have this MPG, right? Now, I'm using some here to count, how many NaNs that we can find in the various columns, right? So if you pick MPG, right, if there were any NaN there, right, then it's going to count and then give the number of counts. So if there were 5 NaN, there's NaNs over there, then it could have given me here 5, right? Or maybe if cylinders were having some NaN there, then it could have given me the number of NaN over here. Maybe it could be, say, 12 or something like that, right? But in our case, there were no NaNs inside here, right? That's why you can see all of them as 0 over here, right? That's why you can see all of them as 0 over here. Now let's check the data type to confirm if what we're seeing is actually what it's supposed to be. Okay, now if we check the data type, right, I'm using the D types over here, right? So in our data, right, this is our data set, right, which contains every data point that we are dealing with. Okay, and then this is some D types. D types is actually helping us to actually find or determine the data type of each of the columns, right? So if we pick each of the columns over here, right, we will be able to actually determine the data type of each of them. For instance, if we pick MPG, we can see that it's a decimal number over here, right? All of them are decimal numbers. So we can say that it's a float data type, right? Like this one, we can say that it's an integer data type. This one will be a float data type. This one will be an integer, a float, right? An integer, and then a float, an integer, right? A unit or an integer, if we want to call it that way. Okay. Now, if we see the data type that we have over here, right? If we see the MPG, right? MPG is float 64, right? That's cool. If we see it, right, MPG is float. Of course, it's form of a decimal point. We expect it to be a float, right? If we see the cylinder, right? If we see the cylinder is in 64, right? It's just either a cylinder is 3, 2, 4, 8, right? So it's reasonable, it's an integer, right? We understand, right? If we see the displacement, it's saying it's float. Of course, it's supposed to be float, right? It's a form of a decimal, right? Now, if we see the horsepower, we can see that horsepower over here is an object, right? Let's go and see. But horsepower, if we eyeball it over here, horsepower is supposed to be an integer, isn't it? But we're saying if we check the data type, it's actually giving us an object data type. Why is that giving us an object data type, right? It means that there are some data points in there which Python is not actually recognizing it as an integer. Okay, there are some data points in there which Python is not recognizing it as an integer, right? So we need to find out what is already there, what is there in that column, which is making this column instead of representing as an integer, it's now being represented as an object. Okay, we need to figure that out and then see what is there, right? We actually did this is NA and then find out that there are no null values in that horsepower, right? So what happens mostly is that if people are collecting data, they have a different way of representing missing values, right? Some those who are actually collecting the data to go and work with it later on with Python, they understand that it's easier if you replace null values, right, data points that are not available with NaN, right, so they can easily work with it, right? But most of them don't actually do this, right? They don't actually do this. Some could represent it with zero, some could represent it with, say, a question mark, some could represent it with maybe no, right? Something like that. So people have different ways of representing data points that are not available. Okay, so if we do this is NA, right, what Python is actually going to detect is looking for this, right? NaN, right? So if it encounters NaN, then it will count how many NaS that are there. Otherwise, if it encounters any of these, right, it will ignore it as not falling into this category, right? It will not realize that any of these are missing values, right? If it encounters any of these, but this NA function will not be able to detect if it is a null value, right? So that's what we actually need to take a critical look at. Okay, so that's why this horsepower, right, might have different data points that were not available, but they were represented in a different way, and our isNA function is not working on that because it's not able to detect that. Okay, now what we're going to do over here is to use this isDigit, right? We're going to use the isDigit function here, okay, to identify that if we go into the horsepower column, right, the horsepower column, that's our interest here, right? So if we go into the horsepower column and then loop through all the data points that we have in the let me go into the column, right? If we go through this horsepower column, right, and then loop through all these data points, right, if we encounter digits, right, if what is there is a digit, right, that's why we're using what is called is digit. Okay, so if we loop through this and then whatever we find over here is a digit, right, whatever we find over here is a digit, then we are going to return true, right? Then we are going to return true, right? Otherwise we are going to return false. Okay, you're going to return false. So if we don't find a digit, then we return false. But if we find a digit, then we're going to return true. So over here, this is a digit, it's going to be true. This is a digit, it's going to be true. This is a digit, this is a digit. So as soon as it encounters a digit, it will return true. If it encounters anything which is maybe in the form of, say, maybe no, or maybe O, right, or maybe a question mark, then it will return false, right? It will return false. Okay, so that's what the isDigit function is actually going to help us to do, right? So let's see it in action, right? Let's see it in action. So what we're doing over here is that we are going into the horsepower column, right? And then we are going to apply this isDigit function over there, right? Then after we apply this isDigit function over there to determine if there are any digit values in, if there's digit, you return true for us. If it's not digit, you return false for us. Okay, then we convert everything into a data frame. All right, we convert everything into a data frame using the pandas data frame function. We convert every result that we get over here, right? Every result that we get over here, we convert everything into a data frame. And then after that, we use this digits. We store every result in this this variable. So this is just a variable name that I'm using, right? Digits in HP, right? It's just a variable name that I chose. So this could have been any variable name at all. Okay, it could be any variable name at all. But as I advised, all right, if you're choosing a variable name, choose a variable name that makes sense to the context that you are dealing with, so that later on when you encounter it in your program, you'll be able to understand. So in this case, I'm using digits in HP. So if I see this variable anywhere, I know that it contains all the digits in HP. Okay, I will get to understand that. All right, now if I show you what is inside this, right, if I show you what is inside this digits in HP, right, let me run that. Okay, now you can see that it's giving me some true in there, right? So if there are any false in there, it's actually difficult to spot over here because I'm giving I'm only being shown with first 5, right, and the last 5. Okay, so whatever is in between here, I'm not able to visualize that, so I'm not able to detect the truths in there if there are any true in there, right? So in order for me to see if there are, the false in there, right, so I'm not able to see the false in there. In order for me to see the false, right, that's what we are concerned with, right? We know that there's a lot of them which are digits, right? Even if we just eyeball it, we know that this is a digit, this is a digit, this is a digit, right? We know that. Okay, What we don't know right now is that if there are any values in this column that is not a digit, right? So that is what we are interested in. So we are interested in finding any false in this, right? Any false in this. So what we are going to do over here is that we're going to, go through, right? We're going to go through this, right? We store everything, all the results in digits in the HP. So we're going to loop through this, We're going to loop through this digit in HP, right? We're going to go through, and then if we find any false in there, right, so we return that. Okay, that's what we're going to find, right? Any boolean. Remember that this is true or false, right? So it's a boolean. So if we find any boolean which is equivalent to false, we actually output that. Okay, so that's what we are actually interested in. Now if we do that, right, if we do that, see the results that we have over here. Okay, now you see that the horsepower column, we have some question marks in there. Okay, so this is what is interfering with when we check the data type, right? This is what is interfering, and this is why this is why our data frame is actually, when we use the d types, it's actually outputting that we have horsepower to be object instead of integer. Okay, because we have these characters in there, right? We have these characters in there, so this is what is interfering, and this is why this column has been identified as an object. Okay. Now, what we're going to do is to replace, in order to work with this as easier as possible, right? In order to get deal with this question marks, right? So as the data points were not available, they represent that with a question mark. So in order for us to be able to deal with this question mark, what we're going to do is to replace all these question marks with numpy nan, right, to replace these question marks with numpy nan. So if you can see over here, right, I'm saying that with df, right, with df replace the question marks with nan, right? So I could have over here, I could have actually specifically selected the horsepower column, right? I could have specifically select the horsepower column and then replace the question marks with nan. Okay, I could have done that, but even if I do it this way, since this is the only column that is having that, right, even if I do it for the entire data set, it's still going to work only on that horsepower column. Okay, so it will go through, and then if it encounters any question mark, it is going to replace it with nan, right? Then after that, right, we cannot actually see it over here, right, because we will have some break over here, right? We will have some break over here. So let me get rid of this one, right? Let me get rid of that one. And then let's see how we are actually going to handle this NaN. Now, since now we have been able to identify that we have some missing data in there, right? We have some missing data in there. We need to deal with this missing data, okay? So what we can actually do is to drop these missing data, right? We can drop them, right? But if we drop them, we are going to lose information, right? Even if it's small, we will still lose that kind of information, and we don't want to actually do that, right? We don't actually want to lose any information over here. So dropping any data point should be the last option that you consider, okay? Because if you drop the information, you lose much. Even if it's small, you will still lose that information. Any information that those data points are going to give you to make better decision, you're going to lose those information, right? If you drop any data point, okay? So that should be the last option that you should do. So let's see how we can handle these data points without dropping them, okay? Let's see how we're going to do that. Now, one thing that we can do is to replace these null values, right? So now we have nan instead of question mark, okay? So now let's see how we're going to do it. We can actually replace this nan with the mean or the median or the mode of the column, right? If we pick the horsepower column, maybe the data points, let me even show you from this one, right? So if you pick the horsepower column, maybe the data point that appears most frequently, right? Maybe 150 appears mostly, so we can replace all the nans with 150, right? We can make as a assumption that it's likely those data points that were were not available could be 150. So since 150 is the number that appears most, right? So we could use the mode concept and then replace those missing values with it. Or maybe we could use the mean or the median, right, to fill up the NANs, right? So in order for us to actually know whether we are supposed to use the mean or the median or the mode to actually do that, right? What we are going to do is to see the distribution of the column, right? So let's see the distribution of the horsepower column. Okay, so I'm going to use the dist plot, right? I'm going to use the dist plot to actually see the distribution of that column. So if I do that, you can see that it's skewed, right? We can see that this column is actually skewed. Okay, now if you have a skewed data set, if you have, a skewed distribution, right, the mean is not ideal for replacing null values in there. Okay, the mean becomes not ideal for replacing. What you can actually use is the median or the mode, right? Or the mode will also help, right? Or the median will actually help, but the mean will actually not help when you have a skewed distribution. However, if you have a normal standard distribution, or the Gaussian, right, what mostly we refer to as the Gaussian, right, that's the normal distribution, then the mean will be the perfect replacement for the NANs, right? So in this case, that we have a skewed data set, or a skewed column over here, skewed distribution, what we're going to use is the median, right? We're going to use the median as a way of replacing the null values in there. Okay, we're going to use that. All right, now let me even get rid of this one. It's not necessary over here. Okay, so what I'm going to do is that I'm going to fill the NANs, right? All the NANs. Remember that I've replaced my question mark with NAN, right? So then the data points that were not available are now represented as NAN. Okay, so I'm going to fill that NAN, right, with the median, right? So I'm going to use the fill NA function, right? As you can see over here, I'm using the fill NA function. So if I pick my data set, right, which is DF, right, I'm using the fill NA, right, function to fill the NAS with the median. Okay, I'm filling the NANs with the median of each of the columns. So if I go through each of the columns, I'm going to, as soon as I encounter NAN, I'm going to fill that NAN with the median of that column. Okay, so in this case, we only have it in the horsepower column. So maybe over here we could have specified that specifically go into the horsepower column, right? We specifically go into the horsepower column and then fill that, right? So we could have actually done that instead of maybe doing it for all the the various columns over there, right? But since we have only this present in the horsepower column, is actually not going to make any difference, because all the other columns are not having any NANs in there, so it's not going to work on them. It's only going to work on the horsepower columns. So whether we bring it or not, it makes no difference. Okay, so we could have we use, in this case, we are using the fill NA, right? So alternatively, we can also use the lambda function over here, right? We can also use the lambda function over here to do the same thing, right? We can use the lambda function over here to fill the same NAN. Okay, so this is an alternative way that you can actually do. Okay, that you can actually do. Now, after that is done, right? After that is done, remember that earlier on when we checked the data type, right? When we check the data type, we're having horsepower column to be an object. So we're going to change this object we're going to change it to a float, right? As you can see over here. So if we pick the horsepower column, right, we're using the as type, right? We're using the as type function to change the type, the data type of the horsepower column to a float, right? From object to float. All right, so if you remember this as type function, as we, in our previous class in the NumPy and in the pandas class, right, we use the as type function to convert a data point from one data type to the other, right? We convert a specific column from one data type to the other. Okay, so we can use the as type function to actually do that, and that's what we are doing over here, right? In the horsepower column, we are changing the object type we are changing it from object type to float type. Okay, Now if we do that and check the data type again, right, if we check the data type again, you can see that now the horsepower column is a float, right? It's a float 64 instead of at first we were having this, right? At first we were having objects, right? We were having it to be object. Okay, now we have it to be float. Okay, now we have it to be float. All right, so this is what we want. Now we have only int and float and some units, right, that we can actually use, right? Now we can build algorithm on this data set, right? Instead of first where we're having these categorical variables. So all these are some exploratory data analysis and data pre-processing that you need to do before you start building your algorithm, right? You need to get your data in order before you start building your algorithm. That's why you'll normally be hearing that most often you spend, about 80% of your time preparing your data, okay? Because building the algorithm is simple, right? If your data is in the right order, is in the right shape, you can easily build the algorithm, okay? But preparing your data to get to that extent is where most of your time is being spent, okay? And it's actually good practice to spend as much time as possible to prepare your data to be in order, because if you feed the algorithm with the wrong data, you're going to get the wrong output, okay? Now what we're going to do is to do some visualization over here, right? To do some multivariate plots over here, okay? We're going to use the pair plot, right? So let's select some of the columns, because not all the columns we will be interested in it, right? If you see what I'm doing over here, right? I'm using the ilocate, right? And then ilocate function, right? And in my df, which contains all the data points that I have, right? I'm going to select all the rows, right? I'm going to select all the rows, and I'm selecting only column 0 to 7, right? Remember that I'm using index over here. I'm going to select only column 0 to 7. So let me show you over here. Let me just pick it up over here, or maybe I should just let me even bring it here so that you get to know what is inside this data, right? So df dot head, right? If I do that and then run it here, okay? So now let me show you what I'm doing over here. Okay, now I'm saying that I'm going to locate, right? I'm using the ilocate, that is the index location. That's what I'm using in this. What I want is to select some columns and then do visualizations on them, right? So I want to select these columns, right? What I don't want is this part, right? I don't want to select these columns. I don't want to do the visualization on this column. So I could have explicitly select these columns, right? And then do the visualization, right? So this is also another way to do it, right? I'm using the iloc to actually do index selection over here, okay? So what is here is that I'm selecting all the rows, right? I'm selecting all the rows. Remember that we have around 398 rows, right? So I'm selecting all of them, right? That's why you see this one. And then for the column, right, I'm selecting between 0, right? So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So I said I want a range of 0 to 7, right? So from 0 to 7, remember that the seventh one will not count, right? It's always one less than the last number that you give. So it's going to end here, right? So that we have 1, 2, 3, 4, 5, 6, 7, right? We have it that way. So the last one that you have here is always minus. It's always going to be -1, which is going to be at the seed 1, right? At the seed index. So we have it from 0 to 6 over here. So this is the column that I want to select, right? This is a column that I want to, that's why I'm giving a range over here. Okay, so if I select all these columns, I store them in what is called attribute select, right? So I just gave this variable name. So this is just a variable name that you could have chosen any other variable name. Okay, now I'm going to use Seaborn, right? In Seaborn we have what is called a pair plot, right? We have what is called a pair plot, and then I'm passing in this attribute select that I've just created, right? And then the diagonal kind, I want it to be KDE. So let's see what this KDE means, right? I'm actually going to show you when I show you the final, the output of this plot. Okay, so if I show you the output of this, see what we have over here, right? If we use the pair plot, right? If we use the pair plot function, we will be able to plot this awesome plot, right? So you see how Seaborn is effective and helping us to be able to plot all these just with with this one line of code. Okay, so with this diag kind, right, it's nothing but the diagonal kind. So this diagonal that you can see over here, right, this diagonal that you can actually see over here. So if I do this, right, so this starting by this diagonals, right? So all these diagonals, this is what this smooth, right? This smooth graph that you can see here is what we refer to as the KDE, right? That's the kernel density estimate, right? It's just nothing but the kernel density, right, estimate. Okay, if we don't specify, right, if we don't specify, let me undo this. If we don't specify, what is going to happen is that if we see that we don't specify this, we are going to have a histogram at the diagonals, right? It's actually running. It's going to take a little bit of time to run. Okay, so let's just give it a little bit of time so that we can actually see what we're going to have at the diagonals. Okay, so now you see that at the diagonals we have histograms, right? We have histograms at the diagonals. Okay, so in order to specifically specify that you want that smooth, smooth curve, right? So we use the diagonal kind, right? The diagonal kind, which is diag kind, because KD is the kernel density estimates, right? So if we run it again, right? Let's run it again. It's actually going to take a little bit of time, so let's see. Okay, so now you see that we have the smooth over here. We have the smooth graph and the diagonals. Okay, now let's take a little bit to look at this pair plot that we have here, right? So the various correlation that we are talking about earlier on, you can see that we have all of them over here. Right, you can see that we have all of them. Now, if you're considering any pair plot, right? If you're considering any pair plot, the upper part, right? I mean, the part above this. Let me bring this and then show you what I mean, right? So we have our diagonal, right? We have our diagonal, right, all the way down. So what I'm saying is that whatever inference that you can get from this top part, right, is the same thing down here. Right, is the same thing down here, right? So you either consider the top part as for interpretation purpose, or you consider the down part as the interpretation purpose. So you can consider either half of it, because it's just the same information that you'll be getting over and over again, right? It's the same thing. So if you see this displacement curve that you can actually see over here, right? If you see this one over here, just the same thing that you're seeing over here, right? This one here is the same thing that you can see over here. This thing here is the same thing over here. Okay, so this one here is the same thing that you're seeing over here. So either half of it, right, is just giving you the same information. Okay, so you don't need to consider here and then here at the same time. You can consider half of it. Either you consider, so if you pick this one as 1, and then this one is 2, you can either consider 1 or consider 2. All right, so let's pick one half, and then I'm trying to see. So if we see here, right, for instance, weight, right? If we trace weight and MPG, you can see that they have negative correlation, right? They have a negative correlation, that is just among weight and then MPG, right? Weight and MPG. If we pick the acceleration and MPG, you can see that it's although it's positive, but it's very less, right? Very low positively correlated over here. Okay. If you pick say weight and horsepower, right? Weight and horsepower is having a positive correlation, right? It's a strong positive correlation over here, right? If you pick, say, acceleration, right, acceleration and horsepower are having a negative correlation, okay? And if you pick, say, acceleration and weight, right, acceleration and then weight, you can see that they don't actually have any correlation between them, right? It's just no correlation that is existing among acceleration and then weight, okay? So all these are some of the inferences that you can actually get from this. If you see the diagonals, right, if you pick, say, the cylinder, for instance, you can see that we have around we have about 3 peaks that is actually trying to show you. So maybe we have cars that use 3 cylinders, some cars use 4 cylinders, some cars use 8 cylinders. So you can see that we have 3 different categories that we can actually see in the cylinder column, right? So it's actually trying to tell you some kind of category that you can actually see in there, okay? It's actually trying to show you some. So all these are some of the inferences that you can get from your pair plot if you consider that when you're doing your exploratory data analysis. All right, now let's move on and then start by building our algorithm, right? Start by building algorithm. So in the next video, what we're going to do is to build algorithm, okay? So what we're doing so far is the exploratory data analysis, getting our data ready to start to build the algorithm, all right? So since now we are done with preparing our data, we can now move ahead to start building our linear regression model, okay? So in the next video, we're going to start building our model. So see you in the next video.